Question 1. From the perspective of energy efficiency and thermal predictability, a new data center in Arizona is being designed by Istas Sanchez with a hot aisle cold aisle containment architecture. During commissioning, it is noted that despite proper alignment of server racks, temperature sensors in the cold aisle are fluctuating and inlet temperatures are approaching upper ASHRAE thresholds. What is the most effective corrective action Istas Sanchez should take to stabilize system while preserving the design intent? A. Increase crack fan speed to maximize cold aisle pressure and reduce bypass airflow. B. Reposition temperature sensors directly in the hot aisle for a better indication of rack exhaust temperature. C. Install blanking panels and seal cable openings under racks to minimize recirculation. D. Switch to a fully liquid cooling strategy using rear door heat exchangers for improved local heat rejection. Answer. Correct answer. C. Install blanking panels and seal cable openings under racks to minimize recirculation. Explanation. In a hot aisle cold aisle containment system, airflow management is critical to prevent mixing of cold supply and hot return air. Recirculation from the hot to the cold aisle due to gaps between equipment or open cable cutouts can lead to elevated inlet temperatures. ASHRAE TC 9.9 recommends using blanking panels and sealing cable penetrations to maintain containment integrity. Increasing fan speed A may reduce some bypass airflow but increases energy usage and does not address root airflow leakage. Moving sensors to the hot aisle B won't help control inlet temperatures. Liquid cooling D is costly and unnecessary for this thermal issue. Question 2. In light of recent developments, EPA-certified technician Izuki is recovering R400 Tina from a rooftop condenser located at a co-location facility. While recovering, she encounters a sudden loss of suction pressure in the manifold gauges and suspects non-condensables have entered the system. Which of the following best describes the compliant and efficient action she should take next? Open the recovery tank pressure relief valve to vent the excess pressure. B. Inject nitrogen into the system to force out non-condensables during recovery. C. Use a vacuum pump to evacuate the non-condensables from the recovery tank. D. Isolate and recover refrigerant to a separate tank, then test for air or moisture content. Answer. Correct answer D. Isolate and recover refrigerant to a separate tank, then test for air or moisture content. Explanation. Per EPA Section 608 and RE Guideline K, suspected contaminated refrigerant should not be vented, illegal, or reintroduced into a clean system. The correct approach is to isolate and recover it into a separate container and send it for analysis or reclamation. Venting via pressure relief A violates EPA rules. In nitrogen B is prohibited during active recovery due to mixing hazards. Vacuum pumping non-condensables from a tank C is ineffective and can be dangerous. Question 3. While examining a pattern of repeated thermal alarms, technician Ista Patel identifies that a specific server row continues to experience periodic overheating, even though the adjacent rows under the same cooling zone remain stable. Upon visual inspection, airflow seems unobstructed and fields are clean. What is the most likely root cause of this recurring issue? A. The BMS set point for that cooling zone is too high compared to neighboring zones. B. The underfloor plenum has uneven static pressure due to poor tile placement or leakage. C. The thermal sensors are malfunctioning and giving false alarms. D. The crack unit is undersized for the current it load across the entire room. Answer. Correct answer. B. The underfloor plenum has uneven static pressure due to poor tile placement or leakage. Explanation. Uneven static pressure beneath raised floors often leads to localized airflow deficiency in targeted aisles, even when crack output is sufficient overall. This is a common cause of isolated hot spots in otherwise balanced environments. Sensor issues C could contribute, but the consistency and location-specific patterns suggest airflow deficiency, the crack being undersized. D would affect all zones, not just one row. BMS setpoint mismatched A would also cause broader anomalies. Question 4. Given the circumstances, Ista LeBlanc is performing service on a data center's HVAC panel board controlling multiple precision air handlers. He has verified lockout-tagout and is now preparing to test for absence of voltage inside control cabinet containing 400 ATIV terminals. Which action ensures compliance with NFPA 7i and OSHA regulations during this procedure? A. Test voltage using multimeter after donning HVACR grade PPE. B. Tap each wire with an insulated screwdriver to verify it's denergized. C. Denergize the upstream breaker and assume the cabinet is safe to touch. D. Remove PPE after turning the main disconnect off before opening the cabinet. Answer. Correct answer A. Test voltage using a multimeter after donning HVACR grade EP. Explanation. NFPA 7i and OSHA 1910.333 mandate verification of absence of voltage using test instrument, and appropriate ARCA flash PPE must be worn when opening panels over 50. Simply assuming denergization C or tapping wires B is unsafe and non-compliant. PPE stay on until absence of voltage is confirmed. D. 8 Calcum suits are common for 400 ATIV class panels. Question 5. Based on the information provided in a monitoring dashboard, a data center reports return air at 76 degf dry bulb and 62 degf wet bulb. Technicians must analyze this for dehumidification requirements using psychrometric chart. Which air property is most relevant to determining if the air is near saturation and may cause condensation at cooling coils? A. Dew-point temperature. B. Sensible heat ratio. C. Relative humidity. D. Enthalpy. Answer. Correct answer A. Dew point temperature. Explanation. Dew point is the most direct indicator of saturation and condensation risk. When coil temperatures drop below the dew point, condensation occurs. While HC is useful, it fluctuates with temperature. Enthalpy D is total heat, and SHRB refers to sensible versus latent load ratio. Psychrometric charts help correlate these properties, but dew point is critical in context. Question 6. Throughout the course of a commissioning checklist, Gomez installs a new crack unit connected to a data center's chilled water loop. She notices the chilled water return temperature is too low, suggesting inadequate heat absorption. Which of the following is the most likely installation-related cause? A. Airflow from the unit exceeds design CFM, overcooling the space. B. Crack coil control valve is stuck in the open position. C. Differential pressure across the coil is too low, restricting flow. D. Return air sensor is located too far from the unit. Answer. Correct answer. C. Differential pressure across the coil is too low, restricting flow. Explanation. Low delta T on the water side typically indicates insufficient water flow through the cooling coil, often due to low differential pressure or improper valve actuation. This reduces heat exchange. An overcooling space A would increase return temp. A fully open valve B would not restrict flow. Poor sensor placement D impacts control but not water return directly. Question 7. With respect to control system interoperability, a data center facility is being upgraded to integrate older air handlers with a new BMS platform via BACNetIP. Mr. Nguyen discovers that legacy controllers are not showing up on the BMS despite physical connectivity. What is the most likely root cause of this integration failure? A. The BMS system is not configured to use Modbus TCP protocol. B. Legacy units may use BACNetIP and require a protocol converter. C. The IP address range assigned to BMS is too broad. D. The controllers are too old to be networked under any circumstance. Answer. Correct answer. B. Legacy units may use BACNetIP and require a protocol converter. Explanation. Many older HVAC controllers use BACNetIP serial communication rather than BACNetIP Ethernet. To integrate the two, a protocol gateway or router is needed. Misconfigured protocol A is less likely if BACNetIP is known. IP range C doesn't prevent device visibility. Age D alone doesn't preclude networking, especially with adapters. Question 8. Examining the consequences of deferred maintenance, Mr. Alvarez observes reduced cooling efficiency and rising power usage effectiveness (PU) in the Tirum Aerator Center. After inspection, he finds biological fouling and scale buildup on condenser coils. What is the most appropriate corrective and preventive action? A. Increase chilled water set points to reduce compressor runtime. B. Clean coils with appropriate chemicals and initiate a coil maintenance program. C. Temporarily bypass fouled units until seasonal demand decreases. D. Add more crack units to compensate for reduced efficiency. Answer. Correct answer. B. Clean coils with appropriate chemicals and initiate a coil maintenance program. Explanation. Dirty coils end heat rejection, reduce efficiency and increase compressor workload. Regular cleaning with non-corrosive chemicals and instituting PM plans restores performance. Adjusting set point C ignores the root problem. Bypassing C may overload others. Adding units D is costly and inefficient. Question 9. During the process of server migration, technician is Rollins must estimate the additional heat load of 15 new blade servers, each rated at 1.2 AW. The power usage is constant and 100% of power converts to heat. What is the total additional heat load introduced into the data center from this deployment? A. 18,000 beta. B. 61,200 beta. C. 45,000 beta. D. 5,200 beta. Answer. Correct answer. B. 61,200 beta. Explanation. 15 servers x 1.2 AW equals 18 AW equals 3,412 beta. So 18 AW 3,412 equals 61,416 beta. 61,200 beta. This direct power to heat conversion is standard assumption in data center cooling calculations. Question 10. The growing trend in immersion cooling technologies has prompted HVACR to evaluate whether to retrofit a hyperscale facility with liquid submersion baths. What is one critical technical consideration before moving forward with immersion cooling deployment? A. The refrigerant charge volume must be increased to compensate for fluid losses. B. Crack units must be reprogrammed to operate at negative pressure. C. Equipment must be compatible with dielectric fluids used in immersion tanks. D. Fire suppression systems must use only due to fluid flammability. Answer. Correct answer. C. Equipment must be compatible with dielectric fluids used in immersion tanks. Explanation. Immersion cooling requires specialized hardware compatible with non-conductive dielectric fluids. Standard components may degrade or fail if submerged. Refrigerants are irrelevant to this design. Negative pressure B applies to containment, not immersion. Code D may be used, but fire suppression selection depends on fluid properties and room configuration. Question 11. While analyzing BMS performance trends, Delaney discovers that multiple crack units in a redundant N+1 setup are operating at near full load during non-peak utilization. His facility has a low average rack density and steady-state server workloads. Which optimization strategy would most likely increase overall efficiency without compromising redundancy? A. Reduce supply air set point temperature to 68 degrees to reduce compressor cycling. B. Decrease fan speed on each unit to the lowest possible value manually. C. Implement load-based sequencing and rotate active crack units dynamically. D. Upgrade to variable frequency drives VFDS for chilled water pumps only. Answer. Correct answer. C. Implement load-based sequencing and rotate active crack units dynamically. Explanation. In N+1 redundancy configurations, dynamic rotation based on real time at loads reduces wear and improves energy efficiency. Running all units simultaneously at partial load is inefficient. VFDS on pumps. D. Help with chilled water, but not crack fan load directly. Manual fan speed. B. Lacks precision and can risk undercooling. Set point say increases energy use. Question 12. To illustrate this point, Ortega is performing a thermal audit in a legacy data center where inlet temperatures vary widely between rows. She notices perforated tiles are randomly placed and airflow appears insufficient in high-density server rows. What should be her first corrective step to improve airflow distribution? A. Relocate perforated tiles to align with high-density cold aisles. B. Increase crack fan speeds across the board. C. Block off hot aisle ends with plastic curtains. D. Install in-row liquid coolers in each cabinet. Answer. Correct answer A. Relocate perforated tiles to align with high-density cold aisles. Explanation. Tile misplacement causes cooling to be delivered where it's not needed. Per ASHRAE TC 9.9, airflow must be matched with thermal load, simply increasing fan speed. B. Wastes energy, blocking hot aisles. C. Helps only if cold aisle airflow is already balanced. In row liquid cooling, D is unnecessary without first addressing basic uninjured. Question 13. The fundamental question is how increasing ambient temperature affects data center cooling efficiency in an air-cooled DX system operating near capacity. Technician Bakshi reports rising condenser temperatures during summer afternoons. Which thermodynamic principle explains the performance degradation observed? A. The system violates the second law of thermodynamics. B. Higher ambient temperature reduces the pressure ratio across the compressor. C. Reduced condenser ambient temperature differential lowers heat rejection efficiency. D. The first law of thermodynamics causes refrigerant superheat to increase. Answer. Correct answer. C. Reduced condenser ambient temperature differential lowers heat rejection efficiency. Explanation. Condenser efficiency depends on temperature differential with ambient air. As ambient temperature rises, less heat is rejected, raising head pressure and compressor energy use. The first law D concerns energy conservation, not efficiency. Pressure ratio B actually increases, not decreases. The second law A is not violated. Governs entropy and direction of heat flow. Question 14. Across different scenarios, Ista Ivanov is troubleshooting intermittent setpoint drift in crack units connected to the BMS. The discharge air temperature fluctuates even under stable loads. BMS alarms indicate frequent command overrides. What is the most likely root cause of this behavior? A. Dirty temperature sensors reducing their accuracy. B. Conflicting control logic from dual setpoint control loops. C. A malfunctioning expansion valve causing uneven coil temperatures. D. Manual intervention by facility staff overriding BMS schedules. Answer. Correct answer. B. Conflicting control logic from dual setpoint control loops. Explanation. Setpoint instability is often due to overlapping PID loops or dual control points local plus BMS. This causes oscillation and overrides. Manual overrides. D can also cause alarms, but wouldn't cycle automatically. Its sensor dirty causes offset, not fluctuation. Expansion valves. C. Affect temperature, but not control loop directly. Question 15. When faced with a sudden chiller failure, ISTA rays must maintain acceptable inlet temperatures for mission-critical servers until backup cooling can engage. The data center is designed with redundant crack units but no redundant chillers. Which immediate action best mitigates temperature rise during the incident? A. Increase supply airflow from crack units using emergency override. B. Shut down non-essential servers to reduce thermal load. C. Activate chilled water bypass valve to circulate ambient loop water. D. Drain chilled water lines to avoid overpressurization. Answer. Correct answer. B. Shut down non-essential servers to reduce thermal load. Explanation. Reducing heat generation is the fastest way to slow thermal rise. ASHRAE recommends load shedding during cooling failures. Increasing airflow A can distribute existing heat but doesn't remove it. Ambient bypass. C is ineffective without active cooling. Draining lines. D is hazardous and not cooling strategy. Question 16. In a modern context of Adobe refrigerants, Islang is selecting a replacement for R134N, a modular chiller system. She is considering R513 and R1234 if both compliant with F-gas regulations. Which factor should be prioritized when choosing the replacement? A. Compatibility with existing oil and seals in the system. B. Evaporator superheat tuning precision. C. Compressor suction line pressure drop. D. System COP under sub-zero ambient conditions. Answer. Correct answer A. Compatibility with existing oil and seals in the system. Explanation. Drop-in replacements must match lubricants, seals, and material compatibility. R1234F and R513 both have different miscibility profiles. Without compatibility, leaks or failures may occur. Superheat tuning B and pressure drop C are secondary and manageable. COP under sub-zero D is less relevant in many data center climates. Question 17. The core principles of electrical safety require Istakolsky to open a 277 control cabinet for inspection. The panel powers several HVAC contactors and motor starters. What is the minimum EPE you should wear during initial opening and testing per NFPA 7-tie guidelines? A. Cotton shirt and safety glasses. B. Class 0 rubber gloves only. C. Arc-rated clothing, face shield, voltage-rated gloves, and leather protectors. D. Flame retardant jacket and hearing protection only. Answer. Correct answer. C. Arc-rated clothing, face shield, voltage-rated gloves, and leather protectors. Explanation. NFPA 7-tie requires Category 2 EPE minimum 8 calcum for systems between 120-600 with potential arc of flash. PPE includes face shields, gloves, arc-rated outerwear, and hearing protection. Lower categories A, B, D do not satisfy the arc flash boundary or incident energy limits. Question 18. As a result of a cooling performance alert, Istacho notes that a crack unit is maintaining supply temperature, but inlet temperatures are high in the nearby rack rows. What is the most probable root cause? A. The return air path is short-circuiting to the supply plenum. B. The supply temperature sensor is defective. C. The humidifier is oversaturating the cold aisle. D. A refrigerant overcharge is causing low delta T. Answer. Correct answer A. The return air path is short-circuiting to the supply plenum. Explanation. A short-circuit return allows cold supply air to loop back into the return without passing through equipment, leading to high inlet temps despite correct discharge air. Sensor issues. B. Would affect setpoint control. Humidity. C. Does not explain high inlet temps. Overcharge. D. Causes core freezing, not this symptom. Question 19. By evaluating the thermal profile of a high-density zone, Fisher notices that the inlet temperatures reach 80 Cudic. The data center adheres to ASHRAE TC 9.9 2021 guidelines for Class 8 equipment. What is the implication of this observation? A. The zone is operating outside of recommended limits. B. The zone is within allowable but not recommended limits. C. The system must immediately trigger an emergency cooling sequence. D. The temperature is optimal for energy savings. Answer. Correct answer. B. The zone is within allowable but not recommended limits. Explanation. For class equipment, ASHRAE recommends an inlet temperature of 64.4 degrees to 80.6 degrees. The allowable range extends up to 89.6 degrees, so 80 Cudic is allowable but outside recommended. Emergency cooling, C, is not yet needed. Optimal, D, would be closer to recommended values for best reliability. Question 20. From multiple perspectives, Mr. Richardson has been assigned to perform quarterly maintenance on several precision air conditioning units serving a Tiroma rate hall. During inspection, he finds that condensate drain lines are partially clogged, leading to overflow in one of the units. Which steps should he take first to properly address this issue and prevent recurrence? A. Replace the drain lines with wider diameter piping to increase flow capacity. B. Use compressed nitrogen to blow out and clear all affected drain lines. C. Increase system static pressure to help push condensate through. D. Add chemical tablets to the drain pan to prevent microbial buildup. Answer. Correct answer. B. Use compressed nitrogen to blow out and clear all affected drain lines. Explanation. Blowing out clogged lines with compressed nitrogen is a standard first response to restore flow. Following that, preventive measures like chemical tablets may help. D. Simply enlarging pipe diameter. A. Does not solve clogging from microbial mold buildup. Increasing system static pressure. C. Won't aid drainage and could affect airflow performance. Question 21. In the absence of centralized chilled water infrastructure, Mr. Nguyen is overseeing the deployment of modular containerized data centers in a remote region. Due to limited power and water resources, he must select a self-contained cooling system. Which option offers the most effective solution under these constraints? A. Liquid-cooled systems with dedicated water loop and chillers. B. Air-cooled DX systems with economizer functionality. C. Central plant chilled water system with underground storage tanks. D. Water-cooled crack units using river water heat rejection. Answer. Correct answer. B. Air-cooled DX systems with economizer functionality. Explanation. Air-cooled DX systems are ideal for modular deployments without centralized infrastructure. When combined with economizers, they allow free cooling during low ambient conditions, saving energy. Central plants C require high infrastructure. River water systems D compose environmental and regulatory challenges. Liquid-cooled systems they need water loop control, are not ideal in constrained locations. Question 22. The effectiveness of system diagnostics comes into play when Ista Silva observes an unusual increase in compressor short cycling in a split system crack unit. This issue developed following a recent core cleaning and filter replacement. What is the most probable cause of the short cycling based on the symptoms? A. Return air temperature sensor was knocked out of position during service. B. Filter replacement increased airflow, reducing cooling load. C. Core cleaning exposed insulation damage causing condensation. D. Expansion valve failed due to temperature shock. Answer. Correct answer A. Return air temperature sensor was knocked out of position during service. Explanation. A misplaced or damaged return air sensor may misread the actual room temperature, leading the controller to turn the compressor on-off rapidly. Core cleaning and filter replacement do not typically cause short cycling unless something is disturbed during access. Other options B, C, D are unlikely without other symptoms. Question 23. Considering the evidence is Mendez is working inside an energized control panel due to operational constraints, testing voltage at terminal supplying 200 ATV to an air handling unit. She is wearing arc-rated PPE and using an insulated multimeter. What is the final safety step she must take before leaving the area per NFPA 7i and OSHA requirements? A. Reset the breaker to ensure continuity. B. Return the equipment to service and notify the building automation team. C. Remove tools, secure panel covers, and document the work in the LOTO log. D. Leave a warning sign for the next technician. Answer. Correct answer. C. Remove tools, secure panel covers, and document the work in the LOTO log. Explanation. NFPA 7i and OSHA protocols require full closure of the panel, removal of all tools, and documentation of the work performed, especially when work was done energized. Warning signs D are useful but not a substitute. Resetting breakers A may not be needed. Notification B is secondary to physical safety practices. Question 24. The development of advanced data center controls has led Ista Yosef to evaluate a building-wide upgrade to adaptive setpoint control using AI-based analytics. He notices that although rack inlet temperatures have improved, crack energy usage has increased slightly. What is the most logical explanation for this trend? A. AI is overcompensating by narrowing deadbands too aggressively. B. The return air damper is stuck in minimum position. C. Crack filters are clogging faster due to higher static pressure. D. Discharge air sensors are no longer calibrated. Answer. Correct answer. AI is overcompensating by narrowing deadbands too aggressively. Explanation. AI-driven systems often reduce deadbands to optimize thermal profiles, but this increases system responsiveness and may slightly raise energy use. Deadband narrowing causes more frequent compressor or fan speed changes. Damper issues B. Filters C. Or sensor calibration D. Would create different performance anomalies. Question 25. When analyzing the performance of a dehumidification system, Mr. Schroeder observes that air entering the cooling coil is at 70 deg dry bulb and 64 deg wet bulb. He needs to determine the moisture removal capacity of the system. Which psychrometric property should he analyze first to understand latent heat removal? A. Specific volume. B. Dew point temperature. C. Humidity ratio. D. Sensible heat ratio. Answer. Correct answer. C. Humidity ratio. Explanation. Humidity ratio indicates the actual amount of moisture in the air, typically expressed in grains per pound or lb moisture of dry air. It's essential for determining how much moisture is removed. Dew point. B tells when condensation starts but not quantity. Specific volume. A is volume per mass, not relevant here. SHR. D is useful for total versus latent analysis but comes later. Question 26. Demonstrated by a recent commissioning review, Claire installs an in-road cooling unit, but notices excessive vibration and harmonics being transmitted through the floor tiles during startup. Which adjustment will most likely eliminate this issue without replacing components? A. Increase compressor discharge pressure via software override. B. Add vibration isolation pads under the mounting feet. C. Change the phase rotation of the blower motors. D. Raise the supply air temperature to reduce thermal cycling. Answer. Correct answer. B. Add vibration isolation pads under the mounting feet. Explanation. Vibration pads help absorb motor-induced harmonics and physical oscillations, especially on raised floors. Changing phase rotation C could damage motors. Adjusting temperature D won't reduce vibration. Increasing discharge pressure A can strain the system and worsen the issue. Question 27. By comparing various refrigerant control methods, Ister is troubleshooting poor temperature regulation in an air-cooled crack unit. He determines the TSV is failing to maintain superheat within expected range. What is the most likely result of a stuck-open TXV in this system? A. Evaporator coil icing and compressor slugging. B. No suction pressure and high head pressure. C. Excessive subcooling at the condenser. D. Constant compressor cycling due to overpressure. Answer. Correct answer A. Evaporator coil icing and compressor slugging. Explanation. A stuck-open TXV floods the evaporator with refrigerant leading to coil icing and potential liquid return slugging at the compressor. This can cause severe mechanical damage. Subcooling C relates to condenser behavior. Cycling D occurs for other reasons. High head pressure B might result later but is not immediate. Question 20. Through careful analysis of system logs, Ister finds that static pressure sensors in the underfloor plenum are giving inconsistent readings, triggering VFD fans to fluctuate. The facility experiences hot spots even under low loads. What is the most appropriate root cause based on these symptoms? A. There is a control signal interference from the BMS wiring. B. The plenum has varying floor tile open area ratios. C. Sensor drift due to age and dust accumulation is causing faulty readings. D. The floor panels are warping due to thermal expansion. Answer. Correct answer. C. Sensor drift due to age and dust accumulation is causing faulty readings. Explanation. Sensor drift from dust or aging leads to inaccurate pressure feedback, especially under floor, affecting VFD-controlled airflow. Inconsistent readings cause erratic fan speeds, producing hot-cold zones. BMS signal issues around would affect multiple points. Tile ratios B affect distribution but not pressure reading. Floor panels D cause structural, not control issues. Question 29. With the advent of low-pressure refrigerants like R1233s, Barnes is recovering refrigerant from a large centrifugal chiller during decommissioning. The system uses a vacuum pump and recovery cylinder rated for low-pressure refrigerants, which special consideration must she account for during recovery? A. Use of a triple evacuation process with dry nitrogen. B. Recovery must begin from the high side and then the low side. C. Use of pressurization to raise boiling point for efficient recovery. D. Continuous subcooling of the cylinder is required to maintain vacuum. Answer. Correct answer. C. The use of pressurization to raise boiling point for efficient recovery. Explanation. Low-pressure refrigerants like R1233s require raising system pressure with heat or pressurization. G. Nitrogen to drive refrigerant out of the chiller and into the recovery cylinder. Triple evacuation A is for moisture removal. Recovery from high-low side. B applies to high-pressure systems. Subcooling D high-pressure recovery tanks. Question 30. Demonstrated by a recent system optimization audit in Atiroma Center, the operations team noticed a steady increase in power usage effectiveness (PU) over several months despite no change in it load. Marcus, the lead HVAC technician, was tasked with investigating the cause. Upon inspection, he found that the return air temperature to the crack computer room air conditioning units was consistently lower than expected. Infrared thermography revealed significant air mixing near the top of the server racks. What should Marcus recommend as the most effective corrective measure to address this issue? A. Increase the set point of the crack units to compensate for the air mixing effect. B. Seal cable openings in the raised floor to reduce underfloor bypass air leakage. C. Install blanking panels and improve containment between hot and cold aisles. D. Add supplemental spot cooling units near high-density racks to improve local conditions. Answer. Correct answer. C. Install blanking panels and improve containment between hot and cold aisles. Explanation. The most effective corrective measure is improving hot aisle or cold aisle containment, including installing blanking panels. This addresses the root cause, return air temperatures being too low due to air recirculation and mixing. According to ASHRAE TC 9.9 and Uptime Institute recommendations, containment strategies ensure separation hot and cold air streams, maximizing crack efficiency and reducing PU. Increasing set points, option A, without solving mixing exacerbates inefficiencies. Sealing cable openings, option B, helps airflow but would address top-of-rack mixing. Spot cooling, option D, may treat symptoms but is not systemic or efficient. Proper containment enhances return air temperatures and system-level performance.